Hello, guys, and we are continuing our study of trigonometry, and we are in section 7.2, which we're going to focus on right triangle geometry. And the objectives for this section are use right triangles to evaluate trigonometric functions. We're going to define trigonometric functions as well. Find function values for 30-degree, 45-degree, and 60-degree angles. Use equal cofunctions of complementary angles. Use the definitions of trigonometric functions of any angle, and use right triangle trigonometry to solve applied problems. And you will need your calculator for this section. Okay, let's begin. So first of all, um, I want to go back to the definition of a unit circle. What is a unit circle? So a unit circle is a circle that's centered at 0, 0 at the origin, and whose radius is 1 unit on the coordinate plane. So this -1 and -1. So such a circle whose radius is 1 and it's centered at 0, 0 is called a unit circle. And we're going to talk about unit circle a lot in this course. And if we pick any point on this unit circle, and we actually draw a vertical line down that gives us the x coordinate of that point. And then if we draw a horizontal line, that will give us the y coordinate of this point. And then when we draw a ray going through from the origin, and that starts at the origin and goes through that point, we're going to call this angle theta or alpha, or in this case, we have t. And this ray forms a triangle, right? Because this line is perpendicular to x, and this line is perpendicular to y. Actually, it forms two triangles, and these triangles are going to be equivalent, actually, because this side equals to y coordinate of the point, so is this side. And then this side of the triangle equals to the x coordinate of the point. By the way, the point has coordinates x, y. And so is this side. So this is the basics of what we're going to be talking about right now. So we have a unit circle. In this case, they showed us only 1/4 of the unit circle. And whenever we have a point on the circumference, then we have a right triangle, or we could extend it to 2 right triangles. This angle will be the same as that angle. And with the hypotenuse 1, okay? Because it's a unit circle and we know that the radius is 1. All right, so keep this in mind. This is a basis for our next sections, but right now we're gonna take the right triangle out of the unit circle and just talk about the properties of right triangles. And then we're gonna put it back into a circle. Okay, so that's where we're going with this. And so in the right triangle, if you remember, the side opposite of the right angle, by the way, I want to emphasize that we're talking about right triangles only, not any triangle, a right triangle with a 90-degree angle. And the the side opposite of this angle is called hypotenuse. And if we focus, okay, this triangle also has two other um, angles. And so when we look from this angle, right, the side, we're going to call this side opposite because we're looking from this point right here. So this side is opposite of angle T, and this side will be adjacent to this angle. So not the hypotenuse, the leg of a right triangle. Okay, so we are ready to define our trigonometric functions. Sine of angle T is the ratio of the opposite side to hypotenuse. Cosine is defined as adjacent side to angle T divided by hypotenuse, and tangent is opposite over adjacent. So these are our basic definitions for our trigonometric functions. Okay, so when this triangle is inscribed in the unit circle, what happens is because the hypotenuse equals 1, right? Our hypotenuse is 1. We have 1 on the bottom for the sine and cosine. And so the sine becomes just opposite over 1. But the opposite is just the y coordinate of that point. So we have y over 1 or just y coordinate of that point. Now for cosine, we have adjacent over hypotenuse, so this side over the hypotenuse of the length 1, so that becomes x coordinate divided by 1 or just x. And for the tangent, we have opposite side of the triangle, which has a length of y, divided by adjacent, which has the length of x. So it's y over x. Again, this simplifies like that only when we're talking about points on a unit circle that form a right triangle. This applies to this part, applies to unit circle only. But in general, this applies to any right triangle. Okay, moving on. For the given triangle, find the value of cosine alpha. So we need to recall, by the way, you have to memorize these identities. These are basic formulas that you have to know at any time. So cosine, if you recall, is adjacent over hypotenuse. So adjacent to angle alpha is this side. So it's 15, and hypotenuse is across from the right angle is 17. So the cosine, the value of the cosine is 15 over 17. And then if you want to calculate the value, is 0.8235. Well, let's round it to 2 decimals, so 0.88. Okay. Next, I want you to try this one. We have a right triangle with hypotenuse 25 and the legs of 7 and 24. And I want you to find sine. And again, pause here and round your sine to, again, to 2 decimal places. Alrighty, so I assume that you did that. And let's talk about reciprocal functions. So we defined sine t, cosine t, and tangent t, but there are also three more functions: secant, cosecant, and cotangent. And these are just, I don't want to say inverses, the reciprocal is what they are. Okay, so if you take sine, for example, it's opposite of a hypotenuse, then secant will be hypotenuse. Cosecant is hypotenuse over opposite. Oh, I didn't notice they position like that. Okay, so I would say this function is a reciprocal of sine, because sine is opposite over hypotenuse and cosecant is hypotenuse over opposite. So it's a flip. Cosecant is a flip of sine. And then secant is hypotenuse over adjacent, and cosine is adjacent over hypotenuse. So secant is a flip of cosine, and cotangent is a flip of tangent. Okay, so tangent is opposite over adjacent, and cotangent is adjacent over opposite. I wish I noticed this earlier so I could align them differently. But this is what I wanted you to know. These are the definitions. And here we are. Basically, what this says, reciprocal functions, it says that sine is a flip of cosecant function, and cosecant is a reciprocal or flip of sine function, and all the rest of the functions, that's the relationship between them. That's what we just discussed. Again, you need to remember those. So why is it important? How does it apply to our triangles? Well, it just goes to show that we could express, functions of this angle in terms of functions of the other angle. Okay, so for example, sine of alpha is defined as opposite side over hypotenuse, right? But if you look at this ratio from the perspective of angle B, that would be adjacent to hypotenuse. So, and if we talk about, for example, tangent, adjacent, so the tangent function is opposite over adjacent. That's for alpha. For beta, it's adjacent over opposite. So that's going to be a cotangent function. So that's why we need to keep in mind those relationships. Actually, let's write it down. So the side opposite of alpha, I'm going to call it A, and the side opposite of beta is B, and the side opposite of right angle is C. So sine alpha is going to be opposite A over hypotenuse C. But when you look from the B perspective, A over C is adjacent over hypotenuse, so is going to be same as cosine. It's cosine of beta. Okay, so these are cofunctions. Now, about cosine alpha. The cosine alpha is adjacent B over hypotenuse, but from this perspective, from the beta angle, B is opposite over hypotenuse, so that's a sine of beta. Okay, And let's talk about tangent. Tangent alpha is opposite of adjacent, so A over B. But when you look from here, this is adjacent over opposite, so that's a cotangent of beta. So these are the relationships, okay? Now notice that all the angles in the triangle always add up to 180 degrees, right? So in the right triangle, this angle is 90 degrees always. So this means that the other two should add up to 90 degrees. So in the right triangle, alpha and beta, they're always add up to 90 degrees. And therefore, I'm going to put the 3 dots here, which means therefore in math language, math shorthand. Alpha and beta are complementary angles. So in other words, if we know alpha, we know that beta is 90 minus alpha and vice versa. They're complementary angles. So we could write these identities as follows. We could say that sine alpha is equals to cosine beta, which is 90 minus alpha, right? For cosine alpha, that equals sine of 90 minus alpha. And tangent alpha equals cotangent of 90 minus alpha. Okay. There you go. I'm sorry I didn't know you cannot see it. So, and these are called equal cofunctions of complements. Okay, cofunction of complements. We're going to come back to them a little later. So cofunctions of complements. Complements. Okay, here we are. All right, let's actually practice what we learned a little bit. So, and we're going to evaluate trigonometric functions of angles not in standard position. So again, these are just angles taken out of the circle, or triangles taken out of the circle. Using the triangle shown, evaluate sine of alpha, cosine of alpha, tangent, secant, cosecant, and cotangent. Okay, so basically it's just applying the definitions. Sine alpha is alpha is right here, so it's opposite 4 over hypotenuse, which is 5. Cosine alpha is adjacent, which is 3 over hypotenuse, which is 5. The tangent is opposite over adjacent, so it's 4 over 3. The cotangent is adjacent over opposite, so 3 over 4. Secant alpha, well, if sine is opposite over hypotenuse, so secant is hypotenuse over opposite. So, and if you already know the sign, you could just flip it. Okay. Sorry, it's for cosecant. Oh, cosecant. Cosecant. And secant alpha is actually a flip of a cosine. So it's going to be 5 over 3. And that's it. That's our 6 trigonometric functions of this triangle. Now I want you to try one by yourself, and I want you to use this triangle to give me 6 trigonometric functions of angle T. And I'll pause here and I'll wait. I hope that you got all of those 6 functions correctly, and I'll see you in the next video.